Okay, in this additional videos, we are going to do another simulations on the stepper motor, but this one we are going to use bipolar stepper, which you can get from the Proteus. You can go back to the components to check the bi-stepper motor. So you can see this is a selections over here. This is bipolar stepper. So it only has 4 connections compared to the previous one around 6. You have to put the ground there. So you just click on this one. You have this one already, so you can drag this one going out. Right, this one going out, sorry. This best stepper. So this is the same thing. Alright, so I just delete another one. So the connections is a bit different. Just now you have to go thoroughly the 6 connections, and the connection is not by the numbering over here, so it will be a different connection. So for the bi-stepper, you are going to connect pin 1 over here, pin 2 over here, pin 3 over here, and the last one pin 4 over here. So this output pin is based on the input pin that you trigger from here. You drive here and this is going to be the output. So remember, on the controlling of the stepper motor, so I'm just going to go through the simplest one, which is a step angle by 90 degree. Alright, so 90 degree is by using this one based on these types of 90 degree. Alright, so I have to remember that what types of step angle that your stepper motor is. So in this case, this stepper motor step angle is at 90 degrees. So every time you drive one time, the angle will be changed up to 90 degree. So for example, that if you have another stepper motor, the spec for the step angle is 1.5 degree, which means that every time this one we're going to have a 5 degree increment, not this one. This is just example of 90 degree step angle. So normally for a stepper motor, it will going to have a very small step angle. So you have to just imagine a clock like this, right? A clock. So you can see the hands off for the second. So every second it will step like this, right? So you can just know that 360 divided by 60, 360 divided by 60 is how much is. So every step angle, this one will be around 6 degree. So that is the example. So this is just a very simple example, but in normal situation for stepper motor, you're going to look at this part. So you have to look at the step angle, means that every angle, it will base on how many stepping can be done. So for example, you want to target around maybe 9 degree. So 9 divided by 9.5, 9 divided by 1.5. So it's going to step up to 6 times. Okay, so I'm going to use this type of driving. Let's look at the Proteus again. So this is the one. So previously you're using this one, right? Using this one. This is for the anti-clockwise direction. So I'm just putting back all the predominant set, because this is just to make sure that your stepper motor, for example this one, right, your stepper motor in is going to have a 5 volt 100% all the time. So in these connections, right, so the enable pin is directly connected to the power. So if you are going to use EN and EN2 put to RC1 and RC2, means that you have to drive this one very high all the time. So it means that your stepper motor will receive a very high voltage around 5 volt over here. Okay, so this one is based on what types of stepper motor that you have. So for example, that your spec for the stepper motor is 24 volt, so you have to change this battery up to 24 volts. You're going to drive this one, else it cannot have enough voltage to drive it. All right. So let's try look back at their programming over here. So if you are using this one, right, 1 1 1 1, which is this one, 1 1 1 1, this is the same one. So you have to go to the other directions to change it, like this one, 1 1 1 1. So I'm going to drag like this. So just build this one again, and then you can run your Proteus simulation. Now you start from 0, 90 degree, 180, 270, 360, 80, 90, 180, 270, and it will keep on rotating based on the 90 degree step angle. So let's try to do the reverse one just now. I'm going back to use this one. So you can comment out this program, and open up this one and build this one again, and run again this one. I'm going to use the same one. This is the same hex file, stem 821. Now you can see the rotation is now anti-clockwise, 90, 180, 270, and 360. So you can drive the directions of the stepper motor on how you drive this one. So right now you are driving from top to the bottom, from RB1 to RB4, RB0 to RB3, and just now previously I just drive from RB3 to RB0. So the continuity of the driving is like this. So you can try by looking at my example here, right? You can try to use the full step drive clockwise direction and look at the results. Okay, I just want to use this is also 90 degree. I just want to use this one, full step drive clockwise, because full drive is 45. This is half stepping, right? 45 degrees. So the 45 degree, this is half stepping. So this one should be half stepping. Let's try. Open up this one. And you can build this one again and run your program. It's 45, 45, 90, 135. So the step angle for this one is 45 degree. So it's correct that when you do this half stepping step angle, you are going to have a 45 degree for this type of motor, which is it can go up to 90 degree. Right, so this is the method how you can drive a stepper motor in this simulator. This is another type of stepper motor, which is a bipolar. Just now it's using a unipolar stepper motor, so it's going to have a different connections. But to conclude in this particular tutorial, that we can just run we can drive a stepper motor by using this driver. You have to know what's the connections over here and understand what is the importance of all these connections. Okay, that's all for the stepper motor. Thank you very much.